Hello and welcome back. In this video we'll be discussing how to solve quadratic equations using square roots. First thing you need to know is when to use a square root. You should only use square roots when you can write the quadratic in this form right here, ax squared plus c. You'll notice that there's one squared term and a constant term, or maybe there's not a constant term, but there's no regular x to the first power. If you have a regular x to the first power, you probably cannot use square roots to solve this. Here you'll see the steps. Typically we'll do the first three. In some cases you have to do the fourth. Move all constant values to the side that's opposite the squared term. So this would be the squared term here. We want to move everything else to the opposite side. Then we're going to divide both sides of the equation by the coefficient. Now, if the coefficient's not a 1, we're talking about the a here. If it's not a 1, you divide both sides by whatever that number is. And then finally, you'll have the square root isolated. So the idea here is to isolate the square root, or isolate the squared term is what I really meant to say there. And in some cases, if the squared term itself happens to be a binomial and maybe something a little bit larger than a binomial, you'll just end up continuing to solve the resulting equation as if it were a regular linear equation. Example 1, we have three different examples here to work with, and you'll see why we have them. So the first one here, a, already has the constant term, which is this one by itself. So what I'm going to do now is divide both sides by 2, and I will have x squared equal to 4. So basically I've ended up isolating the square. Now I want to take the square root of both sides, and I'll have x squared. But keep in mind, every time you take a square root, you actually have two solutions, one positive and one negative. So I can actually write that a couple ways. I can put 4 comma negative 4, or if I wanted to, I could put x equals plus or minus 4, indicating both solutions. Anytime you have a positive number right here, you'll end up having two solutions. Letter B, we're going to move the 18 over by adding 18 to both sides, and I end up with m squared equals 0. And then when I take the square root of both sides, I have m equal, now there's no such thing as plus or minus or positive or negative 0, so I end up with only one solution. So anytime this number over here under the radical is a 0, you'll end up with one solution. Letter C, we're going to move the 12 over first, so minus 12 minus 12. And we have a b squared equal to negative 7. Now we could try to take the square root of both sides. However, there is no way to take the square root of a negative 7. There is no answer to that. There's no solution. So anytime the square root or whatever's under the square root is a negative, you'll have no solution. Example 2, we're going to go ahead and solve for z. So the first thing we do is divide both sides by 4. And I'm actually going to leave that as a fraction. So I end up with z squared equal to 9/4. I'm going to take the square root of both sides. But when I do that, I can actually take the square root of 9 and the square root of 4, the numerator and the denominator, separately. So it's like we're distributing that square root to the numerator and the denominator. We can do that here because we don't have a plus or a minus inside the problem. So I can rewrite that as, and I know that this is going to have two solutions because it's positive, so I'm going to put plus or minus. The square root of 9 is 3, the square root of 4 is 2. So my final solution there would be plus or minus positive or negative 3 over 2, or 3/2. Example 3, I actually have a couple steps. So the first thing I want to do is get rid of all constant values. So I'm going to add 11 to both sides, and I'll have a 3x squared is equal to, now I still have a coefficient over here that's not a 1, that's a 3, so I got to get rid of that first. So I'm going to divide by 3 on both sides. That will become a 1. Now I have an x squared equal to 6. I've now isolated my x squared, or my squared term. Now I can go ahead and take the square root of both sides. Now this is positive, so I can actually write it as x is equal to plus or minus the square root of 6. Or in some cases, if you're required to estimate that, you can use a calculator and do the square root of 6 yourself. So using a calculator, we can see that the square root of 6 is approximately 2.45. I'm going to round that to 2 decimal places, so approximately, and use that symbol instead, plus or minus 2.45. In many cases, when you're using quadratics or solving quadratics, you're going to find out that you're going to have to estimate the answer. Example 4, we see we have no constant terms in between here, but we do have a coefficient out in front. So the first thing we're going to do is divide both sides by 6. So that's going to isolate the squared term here. and that will end up giving us a 7. Now, your first instinct might be to actually try to square this entire binomial out. But doing so will now make this not usable for square roots. Since this entire thing has got a square on it, we can undo that by taking the square root of the left side and the square root of the right side. So now we'll have just an x minus 4 equal to plus or minus the square root of 7. And I'm going to leave that as plus or minus the square root of 7 for now, because I'm not done solving, because I don't have actually x by itself. So I'm going to add 4 to both sides, add 4 to both sides, bring down my x. And I'm actually going to put the f4 up front. It's positive, so I can just write it as 4. And that's going to be plus or minus the square root of 7. So you've actually got two answers there. But if you wanted to estimate those two answers, you'd have to write them like this. 4 plus the square root of 7 and 4 minus the square root of 7. And the only way you can really estimate that then would be to use a calculator. So I'm going to go ahead and use a calculator and estimate those two. So according to the calculator, when I do 4 plus whatever the approximation of the square root of 7 is, I get 6.65. And then when I do 4 minus that same number, I get approximately 1.35. So it's possible to leave your answer like this, but if you need better, closer approximations, then you might want to go ahead and put the answer like this. Example 5. During an ice hockey game, a remote control blimp flies over the crowd, drops a numbered table tennis ball. The number on the ball corresponds to a prize. We want to use the information in the diagram, so that diagram's over here, to find the amount of time. We're looking for time, so we're looking for t, that the ball is in the air. Now this uses the vertical motion model, so if you've not seen that video, you might want to pause this and go back and look at the vertical motion model. Anyway, h is the final height, or the height at any given time above the ground. T, and it's t in both places here, is the time that an object is actually in the air. And v is the initial upwards velocity, so something's going up. And s is the starting or initial height above the ground. So if the object is on the ground before it starts, then s would be 0. So if we look at this, we can see that the blimp is starting at an initial height of 45. So s is going to be my 45. Now the blimp is just going to drop the ball. It's going down. It's not throwing the ball up. So my initial upwards velocity would be a 0. So 0 times t makes this entire calculation right here 0. So I actually drop that out of the problem. So I'm going to bring over my negative 16 t squared, and h, the ball does not drop all the way to the ground, so my h is not 0. My ball is caught 17 feet above the ground, so the final height of the ball is going to be 17. Now I just need to work backwards to solve for t. So the first thing we do is minus 45 from both sides. Bring down my negative 16t squared. And on the left-hand side, we'll have a negative 28. And some of you might be thinking, well, wait a minute, you can't solve that with negative 28. Well, remember, we're not done yet. We haven't isolated the square. So if I end up dividing by a negative 16, that negative over negative will turn that left-hand side back into a positive. Now we're going to actually have to estimate that. So 28 divided by 16 is going to give us about, actually it gives us exactly 1.75. And now I have the t squared by itself. Take the square root of both sides. Now remember, in this case, square roots always end up with two answers, one positive, one negative, but we're talking about a time value in which the ball has been dropped from the sky. So the negative time value wouldn't make sense in the context of the problem, so we simply ignore the negative value. So use a calculator to estimate the square root of 1.75. And when we do that, we get an approximation of about 1.32. Now time is in seconds. So it takes the ball about 1.32 seconds to fall from the blimp to the person that catches it 17 feet above the ground when the ball is dropped from 45 feet.